Hello, you're welcome once again to Taxonomy Online Mathematics, the series on percentages 2, which we are taking tutorial on depreciation. This happened to be episode 13 of the series on percentages and the fourth episode on depreciation. So the cost of an item depreciated according to the table below. First year, there was no depreciation, meaning the value remained the same. Second year, it depreciated 25% of its cost price, if I may say. Then the third year, it also depreciated 10% of its what? If cost price. So if the cost of the item before this depreciation starts is 6,000 Ghana cedis. You have to find each cost at the end of all these 3 years. So let's start by saying that cost of the item after first year. Let me just say use first year. That is going to be after first year, nothing happened. So 6,000 will still be what the value of the item worth. If you want to sell it at the end of the first year, you still have to sell it what? 6,000. Since the rate is what? Nil. There is no rate of percentage. Then for the second year, we can see that the rate of depreciation is what? 25% of the original cost, right? And what is the original cost? The original cost is going to be the cost of it at the end of for the first year. So now we know the rate at which the machine is going to depreciate, right? This rate 25% is corresponding to the value at which the value 6,000 will depreciate. But the value of the machine itself is no more going to worth 100%. So if it is no more going to be 100%, it means there's a reduction in the percentage by the 25%, and that make it 75% value. The value will now worth 75%. So I can say that new value or cost of item, right? After the second year will just be the 75% of the cost of the article at the end of the first year. Right? We are seeing the 25, but you can work with the 25 as the depreciated value, which in this case will be 25 over 100 times 6,000, so somewhere 1,500. Then you subtract that from the 6,000 to get to where we are going, to know the value of the car, of the item, after that 1 year, which is going to be the second year. So let's do that and see. These two zeros will cancel these two, leaving this 60 times 75. 60, 75 will be 4,500. Do we see that? This is 4,500. If you were to add the 1,500 to it, you come back to the 6,000, which was the original price. Now, for the third year, we know the value is depreciating at different a rate of percentage. So we can say that the rate of depreciation is going to be 10% of the cost price. If I want to put it of what? Cost price, right? So let's put it here. So if that is what is going to happen, then the new value itself will be 10% shortage of the 100%. So I can say from here that the cost price or the cost of item, I'm trying to manage space, okay? After the third year will also be that the 10% reduction in the 100% will give you 90% of the cost price. Now remember, we are no more having 6,000 at our hand. We are now having what? 4,500. Remember, you are not going to use the first one. If we are to put years to this, we are in the year 2025. So let's say 2025, 2026, and 2027. You can see that when 2025 comes to an end from January to December, the value of the machine still remains 6,000. Then we are no more in 2025. We move to 2026. So the value here now will become still 6,000, but at the end of this, at December, the value is now going to depreciate 25% and get back to this. So we have ended the year 2026, entering 2027. At that point, we have no value at 6,000. We are working with the market value, which is 4,500. So it means the machine will depreciate 10% of that value, which is why we are using the 4,500. So these two zeros again, cancel these two zeros. So you'll be left with 90 here multiplying 45. 90 times 45, and that will be 4,050 Ghana cedis. So what are we looking for? We are looking for the value of the machine or the item at the end of the 3 years. So at the end of the 3 years, the value will move from 6,000 to 4,050 cedis. I'm sure we understand this also. You can try and see whether the formula method can also be applied here. Remember, it can only be applied per year, meaning the power will only be 111 in each of the stages. Do you get it? For the first year, there is no time calculation you are going to deal with, so we have to work with the 6,000. Try and see if you can use the formula method and arrive at the same value. Thanks for watching. Don't forget to share, like, comment, and subscribe.